Go to TAPgiles.com to learn dreams, engage my services, and support the channel.
So you can use this for some crazy stuff. So if we have, let's get back to having a fat wire. So if you want to know if this changed, then we can do that trick where you kind of loop it into itself, and then you go equal. So if it's equal, then it didn't change in the last frame, and if it's not equal, it did change. And the result, if I put that in there, so when we change stuff, you'd expect it to be like flickering off when we change these values, but it's not because of what we looked at earlier. If we see what's going on when we split it again, so it's giving us 1 for each of them, not just giving us a 1 for its overall equal. So as this one changes, you can see that one flickering to 0 because it's changed. So it does it for each individual one. So if we gave these switches, actually, they'll flicker off as you change the value because over time it's changed. So what we really want to do is know if any of them didn't pass the test, if they're not all equal to 1, or to find out if they are all equal to 1. So if we set these all to 1 and we look at the calculator, you can see what it actually gives us, which is 1.73, and we'll get a number displayer to just make sure we're getting the full picture. So it's 1.732 when they're all 1 because of that magnitude thing. So this is like a 3D coordinate, like in a scene, and the distance from 0 when all of these are 1 is 1.732. So we can check if this test is equal to 1.732. I'm just going to use a combiner, and by default it's on the signal type, which just has a plus and minus, and it adds the plus amount and subtracts the negative amount, and it just gives you a normal number, so it's just a thin wire. But if you take a fat wire and you wire that into the positive, then that's what you get. So if you wire that into the positive, and we see what that gives us, it's giving us that same 1.732. So if we put that into here, then we're finding out, are they all equal to the previous frame? And then we're getting that magnitude thing to kind of summarize if this is all 1s or not. So that will give us a number, and that's giving us the 1.732 value. And we can just check if that is actually the value we're getting using a normal calculator. We wire that in. Is it equal to 1.732? And then if it is, we'll turn on a switch. So now when we change stuff, it's checking if it's different to the previous frame, any of them. So now as we change these values, this is checking to see if any of these values changed from the previous frame, and if it didn't, then it's sending out a 1 for them. So if they're all the same, then they're all 1s, which means that the magnitude or the distance from 0 will be 1.732. So we're checking to see, we're getting that distance value out with the combiner. We're checking with the calculator to see if it's 1.732, and if it is, we're turning that switch on. So if these haven't changed, that will be on. If these have changed, that will be off. So now as we change them, you can see it's flickering off. So we can find out if a 3-number vector type of thing like this has changed at all by using this kind of setup. So all you need is that. So with a real world example, if we just grab a tag, this actually comes with a scene space transform. So which is a fat wire. So if we split that with a splitter, we get a position. If we split that with a splitter, you can see it's a 3-number type of vector like we were using down here. So if we just wire that into here, and we just ignore that one. So as this position changes, we know that it's not equal. So we can detect if something is moving or not just with this maths stuff going on. So this is particularly useful if you are maybe keyframing or teleporting something, because the movement sensor won't necessarily pick up that it's moved because it uses the physics engine, and a teleporter ignores all of that. So this is kind of another way of finding that out, and it actually also works with the rotation, because if we get a splitter, that's got 3 different kind of numbers going on with the different rotations, and it actually has a similar thing happening with the magnitude of how much it's rotated. So this works the same. If we like rotate this, and let go, so then it will. It knows that it's rotated. So this could be like on a character or on like a gun turret or a sword or anything you want, and you can find out if it's moved. Ones that aren't vectors are the transform. The transform has a scale, and it uses the scale as the default value for whatever reason. And color, I haven't been able to figure out what the color is, but most of them make sense. Player info is the highest value of any of these, I believe. Sticks is just a 2D vector. Music, I think, is just power, the volume. That's rotation. Spice, I can't remember what that one was, but I do have them all written down in my docs, which is tapgiles.com/docs. If you search for wire types, it's like the last section, and it lists all of this and goes into all of it.
Thanks for watching. I hope you learned something interesting. Go to patreon.com/tapgiles to learn something new every day.